In this algebra video, we'll look at how to factor a polynomial that has something other than 1 as a coefficient of x squared. To get to that point, we are going to look at a couple other examples that would help us lead up to that. This is an easier example where the coefficient is 1. So you might be able to do this by guess and check and get the answer. And if that's okay, you're good to go. But if you don't have a method for doing this, I want to encourage you to try this X chart. What we're going to do is multiply this implied 1, the coefficient of x squared. We're going to multiply that times negative 28. And then we're going to carry this negative 3 down, and we put it in the chart like this. So what we're looking for is two numbers that when I multiply, I get a negative 28. When I add, I get a negative 3. Here's how I'm going to go about doing that. I'm going to write all the possible combinations that multiply to 28. 1 times 28, 2 times 14. I know that 3 doesn't go into 28, because if I add 2 plus 8, I get 10, and 10 can't be divided by 3. So I know by some divisibility rules that 28 can't be divided by 3. 4 goes into 28 7 times. 5 doesn't go in because it doesn't end with a 5 or 0. 6 won't go into 28 evenly. And then the next number is 7. But you'll notice that I already have a 7. So if I continued going, the only other numbers that are going to work are the 14 and the 28. So I know once I get to this repeat that I'm done. These are the only combinations that work to multiply to a 28. Next, I'm going to look at which ones can be added or subtracted to get a 3. I notice that the 4 and 7 have a difference of 3. I know that one of them is going to have to be negative because when I multiply them, I need to get a negative 28. And when I add them, I want to get a negative 3. So if I'm going to add them and get a negative result, then I know that it's the 7 that has to be negative. So you can check this. Positive 4 times negative 7 is negative 28. Negative 7 plus 4 is negative 3. So these are the two numbers. The 4 and the 7 are the two numbers that I fill into the chart, the 4 and the 7. Do you remember what to do next? I could just take that and say, oh, I'm sorry, I left the negative off, didn't I? I talked about it being negative, but didn't write it there. So I could just fill them in x plus 4, x minus 7. But when I get to a problem that has something other than a 1 here, I am going to have to take it a step further. I'm going to break this 3x into a 4x minus 7x. Here's what it's going to look like. We have x squared and then plus 4x minus 7x and then minus 28. So that 4x minus 7x is the same as the negative 3x. And now I could do what we call factor by grouping. Group these two together and their common factor, greatest common factor is x. If I group these two together, they have a common factor of negative 7. So if I factor x out of x squared and 4x, x squared divided by x is x. 4x divided by x is 4. So I could check this with multiplication. X times x is x squared. X times 4 is 4x. Now let's do the same thing with the negative 7. Negative 7 divided by, or negative 7x divided by negative 7 is x. Negative 28 divided by negative 7 is positive 4. And then notice that I have two identical pieces. I've got x plus 4 and an x plus 4. Because those two match, I can pull out this x plus 4 and when I factor that out, you can see in this black ink what I have left, the x minus 7. And look, that's the same thing I had up here. You don't have to go through this method. We could have stopped when we got the plus 4 minus 7. But notice that this breaking it down into 4 pieces does work. Let's move on to another example. Here's an example that's just 4 pieces. So we'll review a little bit more of this factor by grouping. Now to factor by grouping, I do want to first look for a GCF. I always want to look for a GCF. And this example does in fact have a GCF. The greatest common factor, it looks like an x can come out of everything. I can divide everything by x, right? So when I factor this, I'd have x and then 2x to the 4th. Off to the side, what I'm thinking is 2x to the 4th divided by x. So that's 2 with 4 x's divided by x. 1x divides out to a 1. So I have 2x cubed left. 2x to the 4th divided by x is 2x cubed. Do the same thing for the 5x cubed. 5x cubed divided by x is 5x squared. So we have 2x cubed plus 5x squared. 2x squared divided by x is 2x. It was 2x squared divided by x. So it's like 2 times x divided by x. 1x divides out, and we're left with a 2x. And then 5x divided by x is 5. So there's the first step. I factored out the GCF. Now I'm ready to do a factor by grouping. When I do continue, be sure you don't lose this x. But I'm going to group each of the 2 pieces together and see what is their common factor. So this 2x cubed plus 5x squared, that could be one group, and can factor out an x squared. 2x and 5 don't have a common factor other than 1, so I'll write the 1. So watch what happens when I factor this by grouping. I take my x squared, and I'm thinking, what was 2x cubed divided by x squared? And that's going to be 2x. And then 5x squared divided by x squared would be 5. So we have 2x plus 5. And then we're adding this to the 1 that we already had. The greatest common factor of 1. 2x divided by 1 is 2x. 5 divided by 1 is 5. And notice that we get a common factor of 2x plus 5 for each of those. So the last step is to take that 2x plus 5 from each of them. What does this look like? Don't lose the x. But then I'm going to take a 2x plus 5 and then look at what's left. When I take the 2x plus 5 out, do you see 2x plus 5 divides out of x squared times 2x plus 5, and we've got an x squared. And then when I divide the 2x plus 5 out of 2x plus 5, I've got a 1. So it'd look like this, x squared plus 1. X squared plus 1, and that's it. You can check this with FOIL. You could multiply 2x plus 5 times x squared plus 1, and you'd get the 2x cubed plus 5x squared plus 2x plus 5. And then you could distribute that x into it, and you'd get the polynomial, 4-term polynomial that we started with. Now let's move on to this trinomial, where we'll use an x chart again, but it's a trinomial where the coefficient of x squared is something other than 1. So this is a little bit different. So watch this process. Here's the steps we take. Number 1, multiply the 3 and the 8 to get positive 24. The 24 is what's going to go in the top. The negative 14 just carries down here to the bottom part of the chart. So negative 14 comes from the coefficient of x. 3 times 8 is where I get this 24. So now to do the number chart, I'm looking for two numbers that when I multiply, I get a positive 24, and when I add them or subtract them, their difference or their sum is going to be 14. I'm going to make a list of all the possible pairs. 24 divided by 1 is 24. You could use a calculator for this, by the way. 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. 25 divided by 5 doesn't give us a whole number. And then the next number is 6, which we already have. So we know that we're done. Once we get a repeat, we're done. Do you see any of these that could add or subtract to 14? I see this one, a 2 and a 12. Now we need to look at the signs. If we're going to get a negative sum and a positive product, these must both be negative. Why is that? Because negative 2 times negative 12 gives us a positive 24. But negative 2 plus negative 12 gives us a negative 14. So I know the chart is right. Let's move on to the next step where we'll use that chart. To use the chart, I'm going to break this negative 14x. I'm going to break this negative 14x into two pieces. I'm going to break it up into a negative 2x and a negative 12x. The negative 14x is negative 2x minus 12x. And I'll carry down this 3x squared and plus 8. So you see I've got my original polynomial, the 3x squared minus 14x, broken as 12 and 2, plus 8. Now I'm going to do factor by grouping. For the first two factors, the 3x squared and the negative 2x, I can factor out an x, and the result would look like this. I'd have x times, 3x squared divided by x is 3x, negative 2x divided by x is negative 2. Let me show you off to the side here what that looks like. So 3x squared divided by x is 3x. Negative 2x divided by x, negative 2. That's where those numbers come from. And then the second pair, negative 12x plus 8. Those are both divisible by a negative 4. So I'll do negative 4 into negative 12x is positive 3x. Here's what I'm thinking. Negative 12x divided by negative 4 is a positive 3x. And then 8 divided by negative 4 is negative 2. So there we have it. Those are we're just one step away from the final answer. If I take out the 3x minus 2, you can see what I'm left with. X minus 4. I'd be left with x minus 4, and that's it. You can check this with FOIL, but look at that process and maybe use that process again and again as you try these examples. Should we do one more example just to see if everyone is on track with this? Now, although these coefficients are much bigger, they're still usable. I'm going to use a calculator and it'll be fine. So the first step is multiply 24 times 50. Now 24 times 50 gives me 1200. I'm not going to panic about that. And I'm going to carry down this negative 95. So the first thing is I'm going to multiply 24 times 50 and fill the chart. Next, I'm going to solve the chart. So I'm looking for two numbers that when I multiply, I get 1200. When I add or subtract them, I get a negative 95. Well, 1 and 1200, that's pretty far off, right? That's not likely to be it. 2 and 600 doesn't work. 3 and 400. 1200 divided by 4 is 300. 5 goes into 1200. 1200 divided by 5 is 240. 1200 divided by 6 is 200. 7 doesn't go into 1200. 8 times 150. We're getting closer. 9 won't go in evenly. 10 and 120. So even with this big number, this is really doable. 11, if you do 1200 divided by 11, you see that you get a decimal answer, so that doesn't work. 12 and 100, 13 won't go in, 14 won't go in, 15, so 1200 divided by 15 gives me 80. Oh, I think I found a winner. You see that? 80 and 15 can add to 95. Let me just continue to show you that there's really not a whole lot of different answers. And it goes pretty quickly. If I do 1200 divided by 16, I'd get 75. Divided by 17 doesn't go in evenly. Divided by 18 doesn't go in evenly. 19 doesn't go in evenly. 20 and 60, 20, and you could keep going like that. It really isn't that impossible to get these. It's much better than a full guess and check. But let's see if this 80 and 15 will work. Because 80 times 15 is 1,200, but the problem is that 80 plus 15 is positive 95. Do you see that if I made these both negative, that when I multiply them, I do still get 1,200, but when I add them, I get the negative 95. So it looks like I want these to be a negative 80 and a negative 15. All right, we've solved the chart. Now we're going to rewrite it with negative 95x breaking down to negative 80x minus 15x. So it would look like this. We've got our 24x squared and our 50. But we're going to break that negative 95x into negative 80x minus 15x. And then factor by grouping. When I group these two together, the greatest common factor for 24 and 80, I think, is going to be an 8, probably. So I could divide 8x out of both of them. If I divide an 8x out, what do I have left? 24 divided by 8 is 3. X squared divided by x is x. So 24x squared divided by 8x is 3x. Negative 80 divided by 8x is negative 10. And then for the negative 15x plus 50, I think their greatest common factor might be a positive 5 or a negative 5. I'm going to use a negative 5, and here's why. When I divide the negative 15x by this divisor, I want a positive number. And the only way to get a positive number here is if they're both positive or both negative. Well, I'm stuck with this negative 15x must be negative, so I'm going to try this negative 5. Negative 15x divided by negative 5 is 3x. 50 divided by negative 5 is negative 10. And it looks like we were successful because this 3x minus 10 matched up for both pairs. And then what's left is the 8x minus 5, and that's it. You see, even a big numbered trinomial can be factored with this process. Well, I hope this video was helpful to you. If you practice it a number of times, do the homework that your teacher has given you, or find some additional examples, practice the process, start out practicing it with that example in front of you. Do it again and again until you get eventually to the place where you can do it without following an example, without looking at an example. Good luck in your continued factoring and your continued study of algebra.